Hello! Today we're looking at a topic that some people might be happy to see return, but then for some other people it might be a bit of a controversial one because we are going to be looking at a circle theorem. Because yes, circle theorems are back in Maths A-level 2. Now, before some of you who weren't so happy with circle theorems existing at GCSE start screaming and shouting at the screen, telling me how unfair it is that they're back, let me start by reassuring you that, for a start, you need to know less circle theorems for Maths A-level because you only need to know 3 of them. And then the other aspect to them is, unlike GCSE, where it kind of feels like you're just learning circle theorems for the sake of being able to answer some questions involving circle theorems, all the circle theorems we learn at A-level or use at A-level are ones that we're learning for a purpose. And that's because they're going to help us do some other algebra that we want to be able to do with circles anyway. So, the circle theorem we're dealing with today is as follows. You start by having a circle, as you can see on the screen right now, and the first thing you do is you pick any point on the circle. It can be any point on that circumference. And then you can also pick a second point. Again, that can be any point on the circle, any 2 points we've now got. And what you're going to do is again going to draw a line in between those 2 points. That line, though, has a particular name. It's got a particular relationship with the circle, and therefore it's got the official name of a chord. It's called a chord because it's a line that's going through the circle, somewhere inside the circle, but it doesn't go through the center. If it went through the center, it would be called a diameter. Anyway, once we've got that chord, we're then going to find the perpendicular bisector to that chord. Perpendicular bisector, of course, being a line that's perpendicular, in other words, 90 degrees to the chord we already had, but also, because it's a bisector, that means it's going through the midpoint because it's cutting that line in half. So therefore that would look something like this, and yeah, as I made the point, it's perpendicular to our chord, and yeah, we call that a perpendicular bisector. Brilliant. But why do we care about that? Why is that special? Well, interestingly, as you can probably already see in the diagram, this perpendicular bisector, no matter which chord you drew it as a perpendicular bisector to, the perpendicular bisector is guaranteed to go through the center of the circle. Nice, neat, but why do we care about that? Well, you see, it's quite useful, because if you know some points that lie on the outside of a circle, we can use this circle theorem to help us find what the equation of the circle is. Because all you've got to do is start by picking any 2 of those points as a pair, draw the chord between them, draw the perpendicular bisector to that chord. That's useful because we know the center of the circle must lie somewhere on that perpendicular bisector, but the problem is right now, we don't know where. It's anywhere. It could lie anywhere on that line. So now we pick another couple of points out of those points that we know lie on the circle, and I'm going to pick this pair of points over here, but it didn't matter if you'd pick the third pair along the bottom. And what we're going to do is we're going to find another perpendicular bisector. And so that would look something very vaguely like that. Now, why is that useful? Well, again, we know the center must lie somewhere on that perpendicular bisector, but that's interesting because it now means we've got 2 lines that we know both must go through the center of the circle. But there's only one point that lies on both lines. So therefore, what do you know? That must be the center of the circle. And that is the point of intersection between these 2 lines. So that's where our center of our circle must lie. You can then also find the radius of the circle, because now you've got the center and you've got those points that lie on the circumference of the circle. You can pick any one of those points that are on the outside of the circle, on the circumference, and find the distance between them and the center, and then boom, you've got the radius as well. And that's all we need now to be able to find the equation of the circle, because of course, equation of a circle, you just need the center and the radius values to find the equation, which is something we looked at in our previous, or one of our previous videos on circles. Okay, so let's look at our example. We've got the 3 points that lie on the circumference of the circle, and we want to find the equation of the circle. So it's basically just the process we're looking at just now. I'm going to split the page into 2 to give me a bit more room to work with. And so we've got to pick 2 of the points, any 2 of the points, and start finding the perpendicular bisector for those 2 points. So I'm going to start by choosing a minus 11.5 with minus 4.6. And then we could start by finding the midpoint, and the midpoint wouldn't be the nicest numbers in the world, but that's okay. We got a calculator to bail us out if we don't want to be doing the mental maths. And that will be minus 15 over 2 and 11 over 2. Nice. And then we got to find the gradient, change in y. So 6 take away 5. Because I pick the 6 first on the top, when I do the change in x on the bottom, I've got to pick the minus 4, the corresponding x coordinate first. And that would be minus 4 minus 11. Cool. And that would simplify to 1 over minus 4 plus 11, which is 7. So therefore the gradient of our perpendicular bisector will be the negative reciprocal of that, which will be minus 7 over 1. But we just write that more simply as minus 7. So now we've got the point on the line, we've got the gradient of the line, we can find the equation of the straight line, the perpendicular bisector, which will be, of course, because we're pros, we now use y minus y1 equals m, lots of x minus x1. We're definitely not using the y equals mx plus c method, because that's a bad method to use compared to this one. Because that's already a correct straight line equation, all we've got to do is simplify it. So what we could do is we could then decide to multiply the brackets. This is where you might choose to use your calculator to help you, because you've got to do minus 7 times positive 15 over 2, a positive 15 over 2 because of the minus minus. And if you were to do that, you would end up with minus 105 over 2. Wow. And then simplifying it by adding 11 over 2 onto both sides, we've got minus 7x, and then that would be a minus 94 over 2. Minus 94 over 2 would be minus 47. First equation sorted. On to the second equation, and therefore we've got to pick another pair of points. Just one we haven't chosen already, so therefore I'm going to choose minus 4, 6 with minus 2, 2. Because it's going to have a slightly nicer midpoint, you could say. So therefore we're going to have minus 4 plus minus 2 over 2, the mean average of the x coordinates, and then the mean average of the y coordinates. Because by the way, that's a little trick for remembering how to find midpoint of things. And so therefore the midpoint would be minus 3 and then 4. So a very nice midpoint. Then the gradient, change in y over change in x. That's 4 over minus 2, which is minus 2, but therefore the perpendicular gradient to that would be positive 1/2. The equation of the straight line you gain from that would then be y minus y1 equals m x minus x1, and we just got to do the simplifying of the algebra. So half x plus 3 over 2, and then that will be a half x plus 11 over 2 if we add 4 onto both sides. Nice! So now we've got our two perpendicular bisectors. Now we can use them to actually find the equation of the circle, because we know the center of the circle is in the place where these two lines intersect. So again, splitting my page into two so I've got more room, we do simultaneous equations, because that's how you find where two lines intersect. So we've got a ready-made substitution, so we can just substitute one of the equations in to replace the y in the other one. And now we've just got to solve that. Some people might choose to times both sides by 2 to eliminate the fractions. And so that'll get us back to minus 94 again. So then I'm going to add 14x onto both sides to get a 15x. And I'm going to take away 11 from both sides because that will get me minus 105. Divide both sides by 15 and that will get you minus 7. Funnily enough. Brilliant. So that's the x coordinate of the center. What about the y coordinate? Well, take our x value of the center and plug it back into the line. And so therefore that will get us 49 take away 47, which is 2. So the center of the circle is minus 7, 2. Good stuff. Now to find the radius, well, the radius will be the distance between the center and any one of the 3 points that lie on the circumference of the circle. And we were given, of course, before 3 to choose from. Pick whichever one you like. I'm just going to do minus 11, 5. So let's deal with that. Right then, so therefore the distance would be the distance between the x values, which should be -7 minus -11. And then we're also going to do the distance between the x values, which should be 2 take away 5, or 5 take away 2, whatever you like. It doesn't matter because we're treating them as distances, because then all we're going to do is Pythagoras with them to help us find the diagonal distance between those 2 points. So if you work that out, of course, that first bracket will become a 4. So we've got 4 squared plus -3 squared technically, but therefore that will get us 5. So the radius is equal to 5. Nice, so now we have all the information we need to be able to find the equation of the circle. It will therefore be x take away the x coordinate of the center of the circle, in bracket squared, plus y take away the y coordinate of the center of the circle, all squared. Very bad 2 there. And then that's going to equal the radius squared. So that's a 5 squared, and of course then you just got to tidy it up. So it would be x plus 7 all squared plus y minus 2 all squared equals 25. Ta-da! That is the answer to the question. Now that was quite a long question. It's possible they might help you out with a question like this, not a guarantee, by either already giving you one of the equations of one of the perpendicular bisectors, because it's very repetitive there. So just be aware of that. And the other thing is, this is not the only question that could possibly ask to do with this particular circle theorem. They could ask many other things, but this is kind of the closest you're going to get to a standard question. The other sort of questions you could get asked are ones I would not be able to predict for you off the top of my head, because it's all about problem solving and all that sort of stuff. Okay, hopefully you found this video useful and interesting, and I will see you in a future video. Goodbye.